with regard to tuning, there isn't a huge amount you can do, but we'll see what we can do. Now, the issue you've got is that in the apply process, whether it's redo apply for physical standby or SQL apply for logical standby, there are points of serialization and points of inefficiency. You can parallelize some things, but not others. Then some extra fringe benefits, how you may be able to do zero downtime, what they call the zero downtime upgrade. 12C enhancements, the DBMS rolling package, makes the zero downtime upgrade more feasible. So, beginning with redo apply, physical standbys. Our basic problem is that redo generation is fast, fully optimized. But redo apply is slow. It's random access all over the data files as you apply redo. And that's a simple fact that we've just got to live with. Not a lot we can do about it. You can parallelize redo transmission by raising the max connections attribute. Remember, we did see max connections. We saw it here. Max connections. If you raise that attribute on your, either with Dataguard broker by setting a property, or if you're not using the broker by alter system set, you just adjust the parameter to more connections, that may help with parallelizing transmission of redo. It may help if you find that the lag is the problem. But it's more likely that the delay is network related. And that's where compression will help. Redo reception can be parallelized. That will happen automatically. You will get multiple RFSs spawned. Right. Apply parallelism from 11G onwards is always automatic if it can do it. There's a parameter related to that. Show parameter recovery. In earlier releases, you had to set recovery parallelism. In 11, you don't. MRP will launch slave processes if it thinks it needs them. Right. Logical standby, in some ways, has worse problems because you're generating SQL. And that does cause issues. You can only have one reader to scan the incoming redo. You can only have one builder to build transactions and one analyzer to work out the processes, to work out what's going on. In the manual, we've given the syntax for how to do it. If you see that your logical standby is getting behind, you can add more processes. What you do is 3 commands in the manual. You set dbms log stdby apply set max servers to a nice high number, say 20. Then of that 20, you say how many of them should be prepare servers, how many of them should be apply servers. By default, you get 1 preparer and 5 appliers. And those of you, such as RT, who still have a logical standby, you can do the experiment and see the launching of additional processes. So by default, it's 1 preparer, 5 appliers. But there's procedure calls in the manual, you will give it the extra processes. Network tuning may be important. Talk to your system administrators. Generally speaking, it's all TCP, so you want the biggest buffer sizes you can have. Session data unit size in earlier releases was important. In the current release, 11.2 and 12, it should default to the maximum. Similarly, TCP no delay should default to maximum nowadays. In version 10, you had to set it in your SQLnet Explorer file. Right. Log archive max, but it's really talking to your system. Another thing we should add to this slide, so write it in please, you really should be using jumbo frames. Tell your system administrators if they haven't done it, you want jumbo frames on the network, and that will make much more efficient transmission. The only issue is that jumbo frames usually have to be enabled on your routers. So you want the maximum possible TCP datagram sizes, and you want jumbo frames. The rest, in the current release, default should be okay. Async transport if at all possible. You shouldn't need to raise log archive max processes now. You get quite a few by default anyway. So that's about all you can do for tuning. You're heavily dependent on the network and the serialization that's necessary, that's unavoidable. For standby first caption, possible CPUs and PSUs, this is 12. In 12, you can do patch set updates and CPUs. You can't in 11. In 11, you have to have the same CPU and PSU at primary and standby. In 12, this is different. I was applying CPUs only this morning. That new one that just came out. So, in 12 then, shut down your standby, apply the CPU or PSU, restart, switch over, patch what's now the standby, bring it up. So that's the standby first patching mechanism. Anything less than a CPU you can usually do independently, as long as you always keep the standby ahead. This then is the zero downtime upgrade. Theoretically, I've only been involved in it once, and it was terrifying. The routine is based on logical standby. You create a logical standby, which as we know means creating a physical standby first. So create a physical standby, convert to a logical standby. Get it synchronized. Then you stop SQL apply process and you upgrade your logical standby home. Upgrade it. Restart SQL apply, and that works because streams works across releases. So at that point you have a, say, 11G primary and a 12C standby. Then you switch over to the logical standby. At that point you've got to be aware that if you've got any tables that aren't supported, i.e. tables with user-defined objects if you're in 11, you're in trouble. You've got to be aware of that, of your unsupported tables. You've got the query from Chapter 5 on how to identify them. So you switch over to the logical standby, and from then on, the data will be streamed back the other way. And you probably just throw away your old primary at that point. But if you want to, yes, you could upgrade it. The SQL apply process can upgrade it, in fact, as you run your scripts on the new logical. So that's the technique. You go via logical standby. So I've been involved in this only once, and it does work, but it's a terrifying process. Yeah, it does work. We've got to test and test and test and test. Now, the real problem is these unsupported objects. You've got to work out how to handle those. How to handle them. What works, and is a piece of cake. Sorry, 12 first. Version 12. Dataguard rolling upgrade. Version 12 only, there's a package, DBMS rolling. DBMS rolling is supposed to simplify the entire idea. Previous slide, what I sketched out isn't too bad if it's only two databases. What if you've got a much more complex environment? Now, what if you've got something horrendous like... I've lost it. What if you've got something horrendous like this? How are you going to do an upgrade from 11 to 12 in this environment? What order are you going to update the databases in? Which one are you going to update first? Which one are you going to convert to a logical standby? Which one are you going to roll over to, switch over to? It's going to be horrific if you've got something like this, trying to do the zero downtime upgrade via logical standby. Maybe you choose this physical standby, convert it to a logical standby, switch over to it, and then you've got to upgrade all the others. What order are you going to do things in? DBMS rolling gives you a degree of automation for that. Right, DBMS rolling. It extends the zero downtime update contracts to really complicated environments. It generates a plan. You've got the build plan procedure. And the build plan procedure, you tell it which one should be first. It works out the order in which you upgrade your databases, what they call the leading group and the trailing group. The leading group you upgrade, say you're going from 12.1 to 12.2, because it only works with 12. If you're going from 12.1 to 12.2, the rolling package will generate a plan that tells you which databases you can upgrade to 12.2 before you switch over. Then you do the switch over, and then you upgrade the other databases to 12.2. It's supposed to help you automate that. Clearly, nobody's tested this yet. Why not? Because we don't have 12.2 yet. But theoretically, it will make rolling upgrade of complex environments feasible. Right. So the leading group must be physical standbys. Convert the master to a logical, upgrade, then upgrade the others. Then switch over to the master of the leading group. Yep. convert the logical standby upgrade, then you switch over to the master loop 2 to get a whole set of physical standbys, which you convert to logical and upgrade. Then you switch over to one of them. Your other group then get upgraded after the switchover and reinstated. You hope. That's the idea, though no one knows really if it's going to work. And that's just the syntax for doing it. This works like a piece of cake. This works in version 11, no problem. The zero-downtime platform migration. Your release must be identical, but you've got the cross-platform capability. Current release, 32-bit, 64-bit, no problem. It really only works between Linux and Windows. So you could have a primary 32-bit Windows, create a physical standby on 64-bit Linux. That works. I've even done that. It works. Supposedly Linux and Solaris on Linux, Solaris on Intel works. I'm not sure myself. Supposedly it works. There's a Metalink article that gets updated with the cross-platform capability. When originally announced, it was supposed to work for Solaris on Spark and AIX on PowerPC. That I know doesn't work. But Linux and Windows definitely does. Linux and Solaris on x86, I'm not sure. So before committing to doing any of this, you need to check what's actually possible. So that then takes us to the end. Right. We've now basically finished